Okay, we're on double identity, double angle identity. Okay, this identity will help us to prove some identities in trigonometry. If you could remember from our past video that we I I gave this formula, the addition or subtraction identity of formula, that if you are given sine a plus b is equal to sine a cos b plus cos a, but if it's minus, you use the sign under. For cosine, cos a plus b is cos a cos b minus sine, but if it's negative, you use positive. So for tan, so we're going to continue from here. So double, from the name double, you can easily see that we are to get sine 2a, cos 2a, and tan 2a. So let's start with sine. So sine 2a can easily be written as sine 2a means a plus a. So we have our addition formula now. Using this addition formula, a plus a. So our b is also a. So we change b to a. So it's sine a cos a plus cos a sine a. So we have sine a cos a. This plus, so we have plus cos a sine a. And looking at this, the two, they are the same. So we have 2 sine a cos a, or 2 cos a sine a. So that is our double identity for sine. So for cosine, so 2a is also a plus a. Cosine, we have 3 formulas here. You see one. The first one, let's expand using our addition formula here. So b is a now. So we have b is now a. So we have cos a cos a. We have positive here, so minus sine a sine a. So cos a times cos a is cos squared a. Sine a times sine a is sine squared a. So this is our first formula. But if you could remember from Pythagorean identity, that's my first video, we have that sine squared a plus cos squared a is 1 from our Pythagorean identity. You can use it to get an expression for sine squared and cos squared. So making sine squared the subject of formula, we have 1 minus cos squared a. So making sine squared the subject of formula here, this goes over to be 1 minus that. Also making cos squared the subject of formula. So we're going to use these two and do to get 2 additional identity. So if we want to get cos 2a in terms of cos only, we want to eliminate sine. So we now substitute sine squared as 1 minus cos squared. So you can easily see that this is now, so we are writing in terms of cosine first. So replacing sine with sine squared with 1 minus cos squared. Do you get? Wherever I see sine square, I call it, because I want the answer to be in terms of cos only. So opening this, we have cos square a 1 minus 1 minus 9, so plus cos squared a. So we have that cos squared a plus cos squared a is 2 cos squared a minus 1 here. So this is our first formula, this one. So y this is the second formula. So let's get the last one. So if you want to write cos 2a in terms of sign now. So I replace cos squared with 1 minus sine squared. So it's also equal to, so wherever I see cos squared now, I call it 1 minus sine squared a minus sine squared a. So this is minus sine squared 8 minus sine squared a. So we have minus 2 sine squared a. So this is the third formula. So cos 2a is either this, this, or this. So depending from the question, you know which one to use. So finally, for tan, we have tan using our, so which is tan a plus a. So using our addition formula for tan, so replacing b with a. So remember, we are using positive, so positive negative here. So we have tan a plus tan a over 1 minus tan a times tan a. So tan a plus tan a is 2 tan a. Tan a times tan a is tan squared a. So these are the three double angle identity. So look at this question. Assuming we're asked to prove, to show that this is equal to this and this is equal to this. So these two questions will be based on what I just explained now. So if you could remember, this is tan, and we know that tan is sine over cos. So I'm going to use, remember, because we have 2 cos 2 theta. Remember, this cos 2 theta has 3 identity. This is the first one, this is the second one, and this is the third one. So that's how you prove from this right hand side. Since I have tan is always sine over cos. So I'm going to use cosine identity. That's the cos 2 identity that has only cos, because tan is sine over cos. Why this is settled, we know that sine 2a is 2 sine a cos a from our double identity. This one, that sine 2a is that. So coming to 1 plus cos 2a, if you look back here, I have that cos 2a is equal to cos 2 cos squared a minus 1. Let me just write. If you see, I'm saying that I want to use only cos down here. So if you could remember, I said that cos 2a is 2 cos squared a minus 1. So minus crosses here to be 1 plus cos 2a. So remaining 2 cos squared a here. So I'm going to replace this with 2 cos squared a. So do you see the logic? So we'll continue. 2 cos squared. Okay, cos squared means, okay, let me just write it again. You know, cos squared means cos times cos. So 2 cos cos. So we are left with sine over cos, because we've cancelled this. So which is now tan. So we've proved that. So we use double identity to prove that. So why the second one? This one is not hard. If you could remember, look at this. This is 1 plus cos 2a. Well, what we have here is just theta. So you can easily picture from our double identity for sine that for cos, that cos 2a I won't use the first one. It's 1 minus 2 sine squared, and also 2 cos squared minus cos squared a minus 1. So let's be logical here. This is double 2a. What you have here is a. So assuming we have 4a, so whatever that is here, divide by 2. 2a. So if it's 4a, we now have 2a. If it's 8a, we have 4a. So again, if it's just a, we now have half a. Do you see the logic? If it's half a here, it's now a over 4. Do you get? So that's it. So you can easily see that, therefore, if I write cos a is this, and also equal to 2 cos squared half a minus 1. So if I move this minus 1 here, it's now 1 plus cos a. If I move the minus 1 here, so we have 2 cos squared half a. That's, I'm using this equal to this. So moving minus 1 to the left hand side is now plus 1 plus cos a, giving us only this. Again, if I move minus 2 cos sine squared to this side, this one comes over. We now have that 1 minus. This goes over to this side to be 1 minus cos a. Remaining only this one comes over here. We'll have 2 sine squared half a. So that's what we are going to use. So if you see, they are also based on double identity. So instead of writing 1 minus cos theta, I now replace it with 2 sine squared theta over 2, because they use theta here. Again, instead of writing 1 plus cos theta, I use 2 cos squared half theta. So you can easily see 2 sine squared. Remember, sine over cos is tan. So I'm saying that we have sine squared half theta over cos squared half theta. Sine over cos is tan, so we have square. So we have, that's it. So all these, they are all based on double identity. So thank you.